Hello, my name is Margaret Agbowo. I work this summer at the National Energy Research Scientific Computing Facility in Oakland. It's a center where simulations are run from different scientific experiments so that the scientists can see what their projections are and whether or not they need to change their theories or if their theories are accurate. This experience influences the way I'll teach in the classroom because I'll be able to justify bringing computing into the curriculum. There's a lot of work right now around bringing technology into the classroom and into the curriculum, and I'll be able to say that because the scientific method is going into the direction of being able to come up with theories, perform experiments, and perform simulations as a way of testing theories, that this is a skill that students need to be able to have and be able to practice before they move to post-secondary careers. I'll also be able to share with my students that having computing skills will augment their repertoire in any field they decide to go into. Most of the scientists I interacted with were not actually computer scientists. They actually have very specific specialties, but programming is such an integral part of what they do that they picked it up along the way, although many of them also worked with computers from a young age. So having that skill, no matter what else any of my students are interested in, will be valuable. I'll also be able to share with my students how simulation brings the world into view, meaning when you come up with something, you can't always test a hypothesis, so you use simulations to create a simulated world so that you can test out different theories. It's not possible to go and split carbon atoms every time you come up with a new thought of how to create a new nanostructure. But it is possible to use a computer or a supercomputer to simulate that process and those reactions. And so it's fun to see that kind of thing. Frankly speaking, I've been watching a lot of climate modeling, and the projections and the colors that they use to show the simulations, they're pretty interesting if you were into that kind of thing, of course. But even if you're not, just to see what we're capable of doing now, it's really phenomenal. And the last thing I can take back to my students is that having computing skills and being able to apply logic to any situation will allow them to be very employable in the future. Again, no matter what industry, being able to identify a problem, think through some possible solutions, and select the best course of action, those are very important skills, especially in the world we live in today. So I'm hoping to be able to transfer those skills to my students. What it's like working in an actual research setting. I think the biggest thing for me was that I just became super energized again by being able to think to a higher capacity than I usually have been able to. A lot of problem solving, a lot of really just a lot of things have been brought to my mind that I haven't thought about in a while. So there's kind of a metaphor of cleaning the cobwebs out of your brain. That's the experience I'm taking away. I also appreciate a lot of the innovations that are going on at the lab, that they're thinking about so many problems in society that they're trying to address, not just in energy, or, well, really all related to energy, but the bigger picture is that the national laboratories really are trying to solve some of the problems. And the last thing is that it's been very cerebral. There's been a lot of thinking, and even though I'm the sort of teacher who is on her feet all day for almost the entire school day helping either students or other teachers, this has been a different kind of cerebralness in that I had one project, I had one assignment, and I had to sit through and work through that assignment, which for me, usually I'm jumping all over the place, but in this case, I just finished that one thing. And so that also takes me to the accomplishment I'm proud of, which is that my project is pretty much finished as far as the coding. There's still a lot of work to do with editing, but what I worked on this summer will actually be used by the NERSC. It's publicly viewable nationwide, it's publicly viewable internationally, especially since many of the research teams are cross-disciplinary and cross-national. So anytime you go to the NERSC site, NERSC.gov, or if you go to the Department of Energy, if you visit them in Washington, D.C., you'll be able to see the links that I created, and that's something to be proud of. Okay, thank you to the CSEE of the Lawrence Berkeley National Laboratory and the Department of Energy for sponsoring the internships. I really appreciated the opportunity to work here this summer.